All right, 12.3, 3 lines. Line L is represented by the equation y equals 2/3 x plus 3. Write an equation of the line perpendicular to L passing through -6, 4. Call this line P. All right, so if it's perpendicular, that 2/3 becomes -3/2. We flipped it and negated it. We know it goes through this point, -6, 4. So like always, write out my equation for point slope form. And then I just plug in what I know. The tricky part here is that my x coordinate is negative, so x minus -6, that's just x plus 6. Write an equation of the line perpendicular to P passing through 3, 2. Call this line N. Okay. Perpendicular to P, sorry. So I'm using this equation now. So I know that if it's perpendicular to P, I'm going to switch my slope around. So if I'm using the same, let's just keep on using point slope form. It's much easier than y-intercept form, slope-intercept form. It's perpendicular, so I'm going to flip my slope around. Right, I'm going from -3/2, goes to 2/3. And I'm now using these new coordinates. So my x coordinate is 3. My y coordinate is -2, so y minus -2 is just y plus 2. Okay. What do you notice about lines L and N? Does this always happen? Show or explain your answer. All right, what do we notice? Well, we can notice that their slopes are perpendicular. L is perpendicular to N. Does this always happen? Yes. This always happens. We talked about that in the do now. Right? If, like we said in the do now, I'll just sort of repeat it because it's pretty much the same thing. Let's just label these lines because I think it's kind of hard to know which is which. I'm getting confused myself. So here we've got line L, this is line P, and this is line N. Just so we all are on the same page here. So we didn't know anything about L and N in this problem. All right, when we wrote our equation for N, they were just talking about its relationship to line P, this one that we did in number 1. So we started off knowing that L and P are perpendicular. The second part of information we found out was that P and N are perpendicular. So we can say that really what they're trying to say is since if two lines, right, if L and N are both perpendicular to the same line P, then what has to be true about L and N? And actually, I made a mistake, right? This is not true. All right, if we look at our slopes for L and N right now, are these two slopes that are going to make a perpendicular line? No, they have the same slope. That means they're going to be parallel. So another thing we can say, which is actually slightly different from what we said in the do now. When two lines are perpendicular to the same line, they are parallel. All right, we can sort of show that or prove it. If L and P are perpendicular, then that means if L's slope is A over B, then P's must be negative B over A. Well, if P is perpendicular to N as well, and we already know P's slope is negative B over A, then N's slope has to be A over B because it's the negated reciprocal. Okay, so that actually is a little bit different than what we said in the do now. In the do now, we said when two lines are parallel, they're perpendicular to the same line. Now in this problem, we're saying when two lines are perpendicular to the same line, they must be parallel. They're sort of converses. Remember, converse means saying the same sentence in a different order. The alternate interior angle theorem is if lines are parallel cut by a transversal, alternate interior angles are congruent. The converse of that would be if alternate interior angles are congruent, then the parallel lines cut by a transversal that form them must be parallel. So we've said the same thing, but two different ways, two different directions. All right, so now we're going to prove something. Prove that the line ax plus by equals c is always perpendicular to the line that passes through a, b, and the origin. So, well, really what I want to do, if I want to know if two lines are perpendicular, right, I need to know that their slopes are negated reciprocals. So I got to find the slope. So the first thing I'm going to do for this top line is I want to find its slope. So the easiest way to do that is to solve for y, because then we would get into y equals mx plus b form, where I can clearly find my slope. So first step, subtract ax from both sides. We want to get y alone. by equals negative ax plus c. All right, c is positive, ax is negative. Doesn't matter what order I put them in, but I want it to look like that equation. So I'm putting negative ax first instead of c minus ax. Now I still need to get y alone, so to do that, I'll divide everything by b. We get y equals negative a over b, x plus c over b. The y-intercept is not super important because really the slope is all we care about. So I'm hoping that when I find the slope of this line, it'll be b over a. So they gave us 2 points. They gave us AB, and they gave us the origin. Okay, so if I want to find the change, right, the difference here from a to 0, the easiest way to write that is just a minus 0. All right, and that's just a. My change in y is going to be b minus 0, which is just b. If it's easy for you, think about these if they were actual numbers, right? If they were, let's say if they were -2, -1 to 0, 0, right? +2, +1. It's always going to be the opposite of the number that appears there if it's 0, 0. I could do the same thing with 3, 4. -3, -4. In this case, we have a positive here, but it would really not be any different if I wrote negative a, negative b either. And you'll see that in a second. So slope is just change in y over change in x. So my change in y is b, my change in x is a, or I could say my change in y is negative b, and change in x is negative a, and a negative divided by negative is just a positive, b over a. So any way you look at it, our slope is b over a, which is the negated reciprocal of negative a over b. So we know that these two lines are always going to be perpendicular. That's it.